All right, so I think this is recording. Let's take a look at these three equations. They are rational equations. We see that we have fractions involved, and with problems 2 and 3, we see variables in the denominator. And there's a note on the directions to say to remember to check for extraneous solutions, and that when we have variables in the denominator, we have to make sure that we don't have division by 0. So let's take a look at number 1. Now, with number 1, since I don't have any variables in the denominator, really I don't have to worry about extraneous solutions. The technique that we're going to use with these rational equations is to get a common denominator for all of these terms. So when we look at the first term, it has a denominator of 6, and we look at the other terms here have a denominator of 5, and you can see that a least common denominator would be 30. So I'm going to multiply this first fraction by 5 over 5. So you can see it's just multiplying by the number 1, but we're writing 1 in a clever way so that we can get a denominator of 30. When we look at this next term, we see that it has a factor of 5, that it's missing a factor of 6, that if we multiply by 6 over 6, we're multiplying by the number 1, so we're not changing the magnitude of this term. And on the right-hand side, this constant, we need, again, a common denominator of 30. So we're going to multiply this by the number 1, but we're going to write 1 as 6 divided by 6. So now you can see that we're going to have a common denominator. In this first term, we typically write the coefficient first. And instead of x times 5, we write 5 times x over 30. And here, 3x times 6 is 18x over 30. And 7 times 6 is 42, and that's 42 over 30. So once we have a common denominator for all the terms, we can basically ignore the denominator, because if we multiply everything, both sides of this equation, by the number 30, by that common denominator, we get just the numerator. We just get that 5x plus 18x is equal to 42. And these are like terms. They add together, I believe, to give us 23x. And now if we divide each side by 23, we have 42 over 23. We're just going to leave that as an improper fraction. It doesn't look like there's any common factor. 23 is a prime number. So there's our answer for number 1. Let's look at the second one. Give ourselves a little bit of room here. All right. So this time we do see that we have a variable in the denominator. But we're going to do it in the same method. We're going to get a common denominator. If we have a denominator of x plus 3 and a denominator of 3, and this 6, we can just write it as 6 over 1. So the least common denominator, or a common denominator, just simply multiply these denominators together, 3 times x plus 3. So that's what we're going to go for. In this first fraction, we're going to multiply this by the number 1, but we're going to write 1 as 3 divided by 3. And in the second fraction, we're missing a factor of x plus 3, so we're going to multiply by the number 1. And notice that the numerator and denominator are the same. Now, it might be smart for me to put parentheses around this so that I remember that it's multiplication. Here on the right, I've got 6 over 1, and I'm missing both a factor of 3 and x plus 3. So I multiply by 3 times the quantity x plus 3 in the numerator and denominator, so that's the number 1. So now I have a common denominator. All of these terms have the same denominator, and I can focus my attention on the numerator and set the numerator, that operation, set that equal to each other. If I multiply all of these terms by that common denominator, what do I get? Well, in this numerator, I get 10 times 3, which is 30. Here, I'll take this 10 and distribute it to both of these terms. So that will give me 10x plus 30. And 6 times 3 is 18. And let's take that 18 and distribute it to both terms. So we have 18x plus 18 times 3. I believe that's 54. Let me check that. I don't want to make a mistake on these videos if I can help it. And mental arithmetic is not truly my strength. But yeah, 54 is correct. So now I simply want to solve this for x. On the left-hand side, let's combine these like terms. I've got 30 plus 30, which is 60. If I take away 10x from the left-hand side, I've got to take away 10x from the right-hand side. And now let's take away 54 from each side. And if we divide by 8, 6 divided by 8. Now be careful, don't divide by 6. Divide by the coefficient in front of the variable. And this 6 divided by 8 reduces. You are expected to write your fractions in lowest terms. So it shares a common factor of 2. So this reduces, and I get a solution of 3/4. All right, so let's shrink this up so we can try to do this last problem. Oh, now remember it said to check for extraneous solutions. Maybe I should make a comment on that, because what would have given us an extraneous solution? Well, we can look right here in this factored form, and we can see that x had better not be -3, because if I'd gotten a solution of -3, plugged it back into my original equation, -3 plus 3 would have given me a 0 in the denominator, and 10 divided by 0 is undefined, and we can't have that. So when I'm checking for extraneous solutions, I'm sorry, I should have mentioned that right away, that when I saw that variable in the denominator, make the comment that, hey, x had better not be -3. All right, so let's go to this last one over here. With denominators of x minus 1, x minus 2, and 1, my common denominator is going to be x minus 1 times the quantity x minus 2. So this first term, we're going to multiply this by the number 1, but we're going to be clever in how we write the number 1, and we're going to write it as x minus 2 over x minus 2. When the numerator and denominator are equal like that, that just reduces to 1. Now this next term, we're going to apply that same technique. Some people will say it's a trick, but it occurs so often that it's not really a trick. I mean, you see this very frequently. We're going to rewrite the number 1 as x minus 1 divided by x minus 1. I've written that kind of big. I need to shrink this up a little bit if I can. And scoot it over a little bit. All right, so this 2 over 1, you can't, sometimes students will accidentally forget about that constant on the other side. They'll see that 2 and they just don't think of a denominator being there because it's just the integer 2. But 2 can be written as 2 over 1, and this does not have the same denominator as the other 2 terms. So we have to make sure that we get a factor of x minus 1 and that we get a factor of x minus 2 in the denominator, so that now all these terms on both sides of the equation have the same denominator. When that's the case, we can just work with the numerators, because if we multiplied all these terms by that common denominator, all those denominators would cancel. We would just have this numerator. So 6 times the quantity x minus 2. I'm going to go ahead and distribute that now. I've got 6 times x minus 6 times 2, which is 12. And then I have addition here. And we're taking that that 2x and distributing it to both terms. So 2x times x gives us 2x squared. And distribute it to the second term, and that's minus 2x I've got this 2, and if I multiply these two binomials together, I get x squared minus 3x plus 2. Now, I've almost done it again. I have forgot to mention that I can't divide by 0, and that what to avoid in my solution set so that I don't have extraneous solutions. If I look at that denominator, I'm going to make the remark now to know what to look for, that I don't want a solution of 1, because 1 minus 1 is going to give me 0. I want to make sure that I don't have a solution of 2, because 2 minus 2 is going to give me a 0 in this original equation, and we can't have that. So let's look. This is a quadratic equation with this exponent 2, but I think that those terms are going to cancel. Let's combine. Let's write this in standard form. Let's kind of clean this up a little bit. We've got a term here that's 2x squared. We have 6 x's, take away 2 x's, and that's going to leave us with 4 x's, and then minus 12 on the left-hand side. And on the right-hand side, let's distribute that 2 to all of these terms. 2x squared minus 6x plus 4. So we can see that the 2x squared, those terms cancel. Let's add 6x to each side. 6x plus 4x, 10x. And let's add 12 to each side. 12 plus 4, 16. Divide each side by 10. Recognize that 16 over 10 are both even numbers, and these reduce. And I get 8 over 5 as my final answer. So, hey, I hope that helps. 8 over 5 is not 1, it is not 2, so it is not extraneous. It should check if I plug it in. If I haven't made any silly kind of arithmetic errors, it'll check. I'll leave it up to you to plug it in and check it, though, and let me know if I've done some arithmetic wrong, and I can edit the video. Hope that helps, and I'll talk to you later.